Good morning. I just remembered that Sabrina had asked me this question and I was going to make her a video of it. So this is 2.4, number 10. And what it says is a machinist is required to manufacture a circular metal disc with area 1,000 centimeters. Okay, so the area of the disc, okay, is 1,000 centimeters. So the first thing it says is A, what radius produces such a disk? A. Okay. Well, we're just going to use the equation for a circle. So pi r squared equals 1,000. And then we'll go solve for r. So in this case, r equals 17.8412. Okay, so there's the radius of our disk. Now for B, B says if the machinist is allowed an error tolerance of plus or minus 5 centimeters squared in the area of the disk, how close to the ideal radius in part A must the machinist control the radius? Okay, so the idea here is that we're gonna have a radius. It's gonna be plus or minus 5 centimeters. Okay, for the area. So that means that the area can be between 995 centimeters and 1,005 centimeters. So that's its error tolerance. And so what we need to do is we need to figure out what are the radiuses that go along with 995 and 1005. Okay? So again, we'll take pi r1 squared equals 995, and we'll take pi r2 squared as equal to 1005. So when I do that, I find that r1 equals 17.7966, 7966, 0.7966, and that R2 is equal to 17.8858. And so those are our two radiuses, right? This is the radius that goes along with 1005, and this is the radius that goes along with 995. Makes sense. One's bigger, the other one's smaller. So what the question's asking is basically asking, if you think about this from the epsilon delta perspective, right? The radius, or excuse me, these areas, there are f of x's, because like it's pi r squared, that's our equation, equals 1,000 or equals 995 or equals 1,005. So those are the values that we get for f of x, all right? And so the limit one that we want is going to be the 1,000. It's the one right in the middle. We've got 995 and 1,005 on either side. So the R1 and the R2, they're going to be like our deltas, okay? In fact, what's going to happen is I'm going to go in and I'm going to say, okay, so that distance, okay, the first one, we'll call it delta 1, is going to equal, okay, 17.7966, or excuse me, 17.8412. That's the actual radius for the 1,000 meter area one minus the one for the 995. So 17.7966. Okay. And then our delta 2 is going to equal 17.8412 minus 17.8858. Oh, excuse me, other way around, right? We want the bigger one. So 17.8858, right? That's the top end minus 17.8412. I just did that. You can do it in either direction. Just remember it's a distance, so it's got to be made positive. You can choose, you could just do absolute value if you wanted to too. Okay? So we'll figure out what those are equal to. So when I go and I do these subtractions, I end up with this one. The top one is going to be 0.0446, and the bottom one's 0.0446. Okay? So at least when we're thinking about going out to 3 decimal or go to 4 decimal places, it's going to be 0.0446. That's like the error margin that we have in the radius. So the error margin in the radius is 0.0446. Okay? So that's actually our answer to B, right? We want to be within 0.0446, okay, to control the distance of the radius. Now for C, what it's asking for is, in terms of the epsilon delta definition of the limit as x approaches a of f of x equals L, what is x? Okay, well, x is the radius, all right? Right, that's the one that we're going to find the deltas for, okay? And then what is f of x? F of x is the area, okay? F of x is the area. What is a? A is, and A is going to end up being 17.8412. So that's the value that we're looking for the limit towards, okay? A is the one that goes along with the 1000. Um, L then is going to be the 1000 because it's a value for f of x, right? So we're going to pair up f of x and we pair up x with a. F of x goes with L, x goes with a, okay? And what is the value of epsilon given? Epsilon is 5, okay? It's the difference in our f of x's. That's what epsilon is. And then what is delta? Delta is, in this case, 0.0446, and that is the difference, okay? And actually, difference between A and our outer edges of A, right? So at our 17.8, excuse me, 17.966, 17.8858, and our outer limits for the x's, for the radii, excuse me. All right. So when we say difference in f of x's, what I want to say is that that's the difference in f of a and its outer bounds. So basically what this problem is trying to do is trying to kind of like help you understand the idea of the epsilon delta definition. Um, essentially this is something that we kind of do sometimes do if we want to get like an error boundary for a particular product. We might have a function that gives us what the product is, and then what we need to do is that we need to do something that we're measuring has got to be within a certain set tolerance, all right? And so it kind of tells us how big that tolerance should be, okay? So that finishes it. Okay. Oh, one thing to just focus on here. In this case, delta, right, just ended up delta 1 was equal to delta 2. But remember, delta is going to be the minimum of delta 1 and delta 2 if you're doing your homework. Okay. All right. So this completes the question, right? Basically, what we're going to be doing is, you've got some function work here. Then we have an error bound, all right? And what you're going to do is you're going to figure out what the radiuses are going to be for values of the areas on the error bound. And then we just want to make an interpretation of this problem into the epsilon delta definition, okay? What I should state is that there's not going to be anything like this on our exam. This is just one of those things to kind of help you develop a better understanding of the precise definition of epsilon delta. Okay, so this is done.